When it comes to data warehouses, any system really that's going to be covering data that's going to be managed and stored is going to be used later on for analyzing or historical purposes in some aspect could be considered a data warehouse from what I've read. There's a lot of varying definitions, so to speak, but that kind of is it in a nutshell. With that, data warehouses need to be capable of keeping the input as it was when it put it in, and that remains as non-volatile. If it is not non-volatile, then it would be volatile, which in that aspect would be that the data could be altered or deleted. So when you turn on your computer, you have your session data, and then if you lose power, if you don't have an external battery, or if you abruptly turn off your computer, even when you turn it off, your session data is lost. So obviously, if you have a data warehouse with data on it, you don't want to lose that data that you have in there if you're obviously going to be using that for analyzing it and the historical purposes later on down the road for any predictive analysis or informed decisions. Big examples on this one, you're going to have healthcare, and you're going to have finances. You're going to have the patient lab information. You'll be able to track patient information for their labs, how they're tracking, if they have a sickness or if they have medications you have to track. Additionally, with the stock market, the picture that I have here is from SCHD, or the Schwab Index Fund. And basically what that shows is from a start date of the end of December until the beginning of, well, today, of August 20th. You can see how it goes up and down, and you'll be able to kind of see, looking at the stock market pricing and looking at beneath that with the red and the green, the volume, you can see where it will fluctuate and as well as correlate between the volume selling and buying volumes compared to the pricing, and you can go out even further for stocks and whatever else for any tracking methods you need to do. So in that aspect, you definitely want your data warehouse to be set up in a fashion where you are not losing the data or non-volatile. With a data warehouse, you're going to have a fact table, and the fact table is going to be the central table in the schema, whether it's going to be star or snowflake in design. And the fact table is going to be in the central, and that's going to connect to your dimension tables. Now, if we consider the example from the TV show Deadwood with Seth and Saul, they would have a ledger on the counter that they're always writing all the information down. Presumably, it's going to be the customers, what they sold, what they sold, who they sold it to, and for how much. And whipping up this picture that I made on my SQL workbench real quick, the orders in the center, that's going to be your fact table, and that is going to have the primary key with ID branching off to all the dimension tables, and then your foreign keys would be the customers, the product, the store, and the date, branching off to the corresponding dimension tables that you'll have there. All that data you're going to have in your data warehouse, you're going to have some sort of way to analyze all that data and generate the reports that you need for your business. Now, typically, days of old, you would have a singular person or group, and they would take considerable time to compile and compare all that data to find the trends. And these days, you can have online analytical processing, or OLAP, which is a software that can complete that process rather quickly and efficiently, so the other employees can do other tasks. And this OLAP software will analyze the data that you have input in the database, and it will generate reports and find patterns or problems, or the what-if analysis for your business. And you can even ask the query of what specific examples you want within that. So there are different types of data modeling that can be used. One example is the multidimensional online analytical processing, or the MOLAP cube. So referencing the cube on the right, you can see the products, geography, and time. So you can just type in to a query, you could ask which location, let's say take Portland, you could say, for Portland in Q1, how many tents did I sell? Or you could have it compare the jackets compared to the cookware sold between Seattle and Boise for the second and third quarter to see which ones are better. So you can find different trends find different patterns and everything, see if there's any uptick or any problem areas that need to be taken care of. Continuing on with the MoleApp Cube, I will be referencing the picture on the left. And with the MoleApp Cube that you'll have, there's different type of actions that you'll be able to use with the OLAP software. So if we reference along the cube along with going off of the example from Deadwood and the hardware store with Seth and Saul, you're going to have your overall large cube with all your data information there, and then you can break it down and manipulate it to see the data in different ways on how you see fit. So with slicing, you can look at the one layer. So if Seth and Saul want to look at the sales from one certain year, they could slice it down to only look at that one singular layer. Now, if they continue on and they want to break it down further, they could dice it and they could choose a smaller subcube. So if they wanted to pick the sales from a certain year and then go further on down to pick, let's say, the mining equipment for shovels and pickaxes, they could go off of that and see how much the miners are spending for equipment for a year. They could use the roll-up action, which is going to be a more general and summarized view, and instead of looking at your individual product sales, you're going to be looking at the numbers for the total mining products sold per the year, and that's going to give you a big picture of whether a business is it growing, is it slowing, are there problem areas, are there certain types of patterns, and then you could even roll down or drill down for a more detailed view. And where you would start with your annual sales for mining equipment, you could drill it down or roll it down to quarterly, and then you could do monthly, and you could keep going down to weekly, and you could see if there's spikes that might correlate with seasons, or was there with Deadwood, was there a gold strike nearby? Was there something correlating with why the trend trended the way it did with ups and downs? And then finally, there's the pivot. And with that, you can turn the cube and you can compare the different aspects and categories from different angles. So first, Seth and Saul chose to look at the products. They looked at the shovels and they compared it to the pickaxes, and then they compared it to the pans. So they could look at the data to look at the item, and then they could switch things over if they wanted to switch it up from mining for the customers. Then they could switch it over to other things for like the homesteaders that are there, even the other business owners like the saloon owners that were there, and see who bought what and correlate it to different types of categories by manipulating the cube in that fashion from different areas. So it comes in handy for the OLAP cube and to be able to manipulate it for different actions to analyze and look at the data from different angles. With all your data, you are going to want to extract some sort of information from that or data mine it. So you can end up with either patterns or trends or possibly anomalies that can help you create some sort of informed decision or prediction. Now, the applications for data mining are pretty much endless. Some of the notable fields that utilize data mining, though, are weather forecasting, healthcare, and sales. With that, there are a number of approaches that you can use for data mining. One of them is the association rule learning, or basically the patterns of things that often happen together. And that can be broken down further to multi-level quantitative or multi-dimensional. Now, multi-level is going to be the different layers of the data. You go from year, and then you break that down, or you zoom in further and you can look at the month. You can zoom in further and look at the week, like that. You can have quantitative, and quantitative is going to be analyzing the actual measurable numbers, the numbers of the sales, the products sold, the total profit. You want to actually look at the numbers to know if you're actually making progress or if there's faltering somewhere along the way. Now, multidimensional, this is similar to the MoleApp, where you're going to be taking different views of the data, such as the customer's products, the time, the location. You can switch that around. You can look at the sales for the products, and then you can switch it and look at the sales for the products at a certain time, and then you can switch it and look at a different direction for the customer type who's going to be buying it and things like that. There's another one where it's going to be the sequential pattern mining, and basically that is your data is going to be applied to show different patterns in a specific order. So if you had the hardware store, you would say that the data might show that the miners are prepping their mining sites at varying times between the seasons instead of stockpiling all the supplies at once. So you could have a miner buying waterproof boots or canvas tents when the temperature starts dropping in preparation for winter, and following that they'll buy gloves and oil lamps at the beginning of winter, and then when it's the dead of winter, when it's cold and everything, they're going to need additional oil and canned foods to last them through the season. So in that aspect, you would have things along those lines. And sequential pattern mining comes in handy as well. That can be frequently seen current times with retail stores, and they'll have certain decorations or certain clothing articles sold at different times of the year because that's when the offerings are going to be needed most based on the trends and the patterns for the weather and also the uptick in buying from customers. Finally, we move on to the podcast Brown Box, which followed a reporter, Gabriel Mack, through working for Amazon warehouse. And with that, there's a correlation between a Amazon warehouse and a data warehouse, where the products that are picked, packed, and delivered from an Amazon warehouse to a consumer, similarly, it's going to relate to how data in a data warehouse is being data mined and then analyzed, and reports are generated for a business or consumer of some sorts. And going to current times, the data warehouses that I looked at, Amazon actually has redone their data warehouse and a lot of their computing systems, and now they have the AWS Redshift, which is a platform as a service. And with Redshift, it is column-oriented and massively parallel processing, MPP, and that creates much faster queries for better order compression compared to the traditional row and column orientation, because that's how the compression is much easier when it's column compared to the column and row. And with that, it'll also create the faster queries to make everything much more faster, quicker, and just efficient overall. And with Amazon Redshift, it'll support all the AWS products for the analytics and machine learning, all the different types of database services, and the real-time insights. With that being said, the drawback is Amazon Redshift only runs on the AWS cloud, along with all the other apps and softwares that go along with it. So it is nice that AWS is all-in-one as an all-in-one platform. However, if you have other databases that are using other programs, it will not work with Redshift. In the meantime, you do have to make a choice of the nodes that's going to affect the storage and the performance based on the pricing. So obviously, if you use higher-end nodes for higher storage, higher performance, that's going to cost more in the long run. On the flip side, as a competitor, there is Snowflake, which is an SaaS or a software as a service. And whereas Redshift offers the features for the AWS cloud only, Snowflake actually supports multi-cloud services such as Google, Azure, and AWS. So there's much more compatibility and flexibility with Snowflake compared to Amazon. Snowflake does exhibit similar cloud data warehousing with the column orientation and the MPP, which does have the fast queries and the better compression compared to the traditional row and column orientation. But it is similar in that fashion. It is a pay-as-you-go and does not have an infrastructure, unlike Amazon, which it has an infrastructure in the fact that you have to do the node. But Snowflake and Amazon are similar in sorts, depending on the needs of a business or the consumer at hand. It's going to depend on what they'd like better. Also for the pricing and the storage, it would have to look at the brass tacks of everything. But in the end, Amazon Redshift is all-encompassing on the AWS cloud, and Snowflake does give a little bit more flexibility if you have other cloud services that you need to incorporate as well. If you have other databases that are already using these services, Snowflake is on top when it comes to that, since it has multiple compatibility with different cloud services.